Okay, good morning, everyone. Thank you so much for coming out to this early session. We're really excited to present a tech talk on critical minerals and the circular economy for batteries. I really wanted to thank my co-organizers for this event, Varun and Isabel, and the organizers of this conference. And I want to welcome our speakers, Dr. Laurent Pilon, who's a director at RPE, and Mary Schilling, who comes from Glencore. This tech talk is going to feature a panel discussion moderated by Varun, followed by an audience Q&A session. We hope you find this discussion very valuable, and we're really looking forward to hearing everybody's insights. So I'll let Varun take it over. Thank you.
Thank you very much, Eddie, for that introduction. Good morning, everyone. My name is Varun. I'm a sophomore at Yale College, and it's my privilege today to moderate this discussion on critical materials and the circular economy in batteries. As somebody at the very beginning of the clean energy journey, it's immediately apparent to me that the critical materials space is deeply intricate and very nuanced. In fact, I told my parents I was moderating this panel, and my dad remarked to me, critical materials are a lot like toilet paper, in the sense you don't want to be in a situation where you really need them and don't have them. And I'm very grateful today that we're joined by two people who will ensure that we are not in that situation. Before we start in earnest, I think it would be great if the both of you quickly introduced yourselves, talked about your respective journeys, your backgrounds, and the why you're passionate about this space. So maybe Dr. Pilon, you go first, and then Mary.
Okay, yes, thanks for the invitation. I'm program director at RPE. I'm also a professor at UCLA in mechanical and aerospace engineering, and I'm on loan to serve the US government, the US Department of Energy. Instead of talking about me, I'd like to introduce RPE because I think some of you may not know what it is. We are based out of the DARPA model, the Defense Advanced Research Project Agency. But instead of focusing on defense, we focus on energy. We do high risk, high reward research funding. So we fund teams here at Yale and all around the country, companies, national labs, companies small and large. And we also have a focus on tech to market. So we want technology that matters. And the motto we have, and I'd like to pass it on to you, because when you think about your research or your technologies, what we always ask when we give money is, if it works, will it matter? We don't want just things to work, we want things to matter. And particularly in the framework of the energy transition and how much critical minerals we're going to need for that.
Thank you very much. Mary.
Sure. I had some slides with my, just mostly to show some pictures. But my name is Mary Schilling. I graduated from Yale College in 2020. I was in Saybrook, the best college here on campus. And then directly actually out of school, I graduated. Switch over. Yeah, so there's proof of my my Saybrook affiliation and my genuine love of Yale. I had a fantastic time here. But directly I graduated actually into the COVID pandemic. I was, thankfully, I would say the lucky class of affected students in the sense I graduated in 2020, so only sort of got my last few months impacted. But after I graduated, I joined Glencore right after graduation and have been in our recycling team since I started. So to explain a little bit about recycling and why it's sort of relevant here and what I do, we at Glencore have a number of physical assets that we move materials through. So we will purchase electronic scrap, lithium-ion batteries, your old cell phones, things of that nature, and then we will put it through, we'll process it, shred it, and then put it through our physical smelter and take out and extract those critical materials that we're talking about now: copper, gold, silver, lithium, cobalt, nickel, all of the materials that are necessary sort of in the background that kind of keep our life advancing every single day. So that's kind of a bit about my background, and then sort of why I'm passionate about this space and this and critical minerals and recycling circularity. There's a lot of impact that we can make here. It's a really I wouldn't say it's a particularly new industry, actually. Recycling has been being done for quite a long time, but maybe it's becoming a little bit sexier now with the lithium-ion batteries and sort of the electric transition that we're making as a society. But there's a lot that can be done. There's a lot of impact that we can make. I think we heard a little bit about that in the keynote address yesterday. There's a lot of room for the government to step in, regulations to come in and make a big, significant difference. There's a lot of room for innovation, technological advancement, and I know that we'll talk a little bit more about this over the course of this discussion with Varun's good questions to come. But overall, as I'm sure Dr. Pilon will agree, it's a very exciting space. There's a lot of movement that can be made, a lot of new developments that can happen, and a real impact that can be made in what I would say is a relatively short amount of time. We can really get collection up and gather up these kind of old devices that have the existing material, avoid them going to landfill, avoid having to mine further damage the earth, and kind of take advantage of what we already have produced and make the best out of those existing materials. And then just this slide is kind of to show, was more of a visual to show that impact. Obviously, this isn't everything here, but this is just an example of some of the materials that we have every single day that we can recycle, put through various different processing and technologies that we'll discuss a little bit further, and then get out all of these critical materials that we need. They are existing already, they're in your hand, they're in your pocket, they're probably sitting, quite a few old phones sitting in some of your desk drawers at home. All of that has material that has already been mined from the earth, and we can avoid having to mine for further and actually recycle and get those put back into new products.
Thank you very much. Thank you both. When I asked people for advice on how to moderate the discussion such as this, I was told to look for intersections between both and kind of explore them. And I think in our preliminary discussions, it's very readily clear that there is a lot of intersection. So I wanted to hear from you both first, as somebody from a public research perspective, somebody from a private stakeholder perspective. How do you see your approaches and remit overlapping and dovetailing, and how do they differ? Why don't we start with the topic?
So we support research to accomplish a specific objective that is good for the country. So at ARPAI, we are not in the business of regulation, which could affect significantly the operation of Glencore, but we try to de-risk technology. So for example, recycling is a very energy-intensive process. It also releases a lot of waste, so CO2. So maybe this is something we are concerned about. So we could work together. They may have technology they are not ready to adopt, but they are looking into it and they'd like to de-risk them before adopting them at large scale. What we like about a large corporation is that they can scale things. They have the teams, the engineers to be able to take a lot of waste, for example, and do big operations. So we just need to help them in their process to improve their technology. So that's where I think we can work together. And we would work with small companies and large companies.
I think from our perspective, as a private company, obviously we need to make a profit, we need to make a return for our stakeholders, but that goes hand in hand sort of with developing for technologies that are cost effective while also being profitable, while also hopefully having a positive environmental and global impact. The government, I would say, maybe less specific, say to ARPA-E, but in general, with recycling, the government we need to be working very close together, working hand in hand. Recycling in particular, a big hindrance to recycling is feedstock. Because people keep their cell phones in their drawers. People don't necessarily go out and it shouldn't necessarily be on the consumer to to have to know exactly where to recycle their materials. But obviously corporations aren't always inclined to take that additional cost onto themselves. That's where it's necessary, I would say, from our perspective, for the government to step in, because we need higher regulation to help keep material domestic, to actually aid in collection, aid with consumer education to make sure that people have an understanding of why we need to collect the material to be able to recycle it. So I would say there we go hand in hand. Of course, on the other side, as I mentioned, as a corporation, we need to make a profit. So that obviously then will sometimes impact the decisions that we make. But on that end, I would say that I saw a poll actually on the app. Someone asked, would you pay more for recycled material? And the answer that someone said, which I appreciated, was absolutely not, with a bunch of exclamation points. And for a while, this is a question we've been trying to answer ourselves, is will people pay sort of that green premium? And the answer seems no. We need to find something that's, maybe there are certain companies that are willing to sort of put that additional dollar into investing in a greener technology, but we actually really will need help from the government to sort of make what will initially probably be a much more expensive transitional process a little bit more cost effective. And therefore appealing to corporations.
Thank you. I wanna highlight what you said about regulation, right? Because in our preliminary discussions, Dr. Pilon, you very lucidly highlighted to me that any kind of regulation that is instituted kind of encourage recycling behavior should eschew using things like fines and legislation, and it should rather focus on consumer behavior. So I want to talk about the role of the government, as in how do you both see the role of the government in developing the recycling value chain? And, you know, Mary, are you of the same opinion as Dr. Pilon? What role do you both see the government taking as we move forward? Mary, what do you go first?
Sure. Yeah, it was sort of as I was mentioning, I think a big driver for us, with specifically for lithium-ion batteries, something that was very exciting, was the Inflation Reduction Act. It got a lot of attention, into the space. It brought a lot of money into the space, which was helpful for sort of kickstarting smaller startup companies that are developing the technology that we're going to need to make this transition. But that being said, you need the government's to step in and sort of provide that funding to help. That's kind of where the role also, I would say, of corporations needs to step up. I think we'll talk about this in a bit later, but it's going to be difficult for smaller players to make such a splash in this space. The people that are directly sort of dealing with the critical materials space are very large organizations, huge auto companies, huge electronics manufacturing companies. So they're not necessarily willing, without some government support, to make investments, I would say, into technologies that are maybe more uncertain or a market that's not so sure at the moment. But I would say the Inflation Reduction Act was really helpful. It put a lot of money into these small organizations that I'm mentioning, and then also sort of kickstarted thinking and got the consumer base thinking about moving forward on recycling, but having an idea about just really understanding where your materials in your devices are coming from, sort of having more of an understanding of our global impact with how supply chains are impacted and how globally they're interconnected. So it's important for the government to step in and sort of help educate and also, help with funding sort of in between, while companies are in the private sector is becoming more confident with the direction that the market is moving.
So I'm not sure I can speak for the government as a whole, but the US Department of Energy has invested hundreds of millions of dollars in the last 2 years through the IRA to develop recycling capacity in the US. Developing new design, new recycling processes, and just building factories to recycling plants all over the country, in New York State, for example. So through different mechanisms. We at ARPAI, we are not doing regulation. We are actually banned. We cannot influence regulation, so I'm not going to talk too much about this. But we don't have roadmap, so I can tell you how I see it, because we have a program, I created a program called Circular, where that kind of goes a little bit perpendicular to the recycling thing. I don't want to give the impression here that circular is the same word, is the synonym of recycling. Please, this is a simplification we certainly do not want to have and make. Circularity for us is to look at prolonging the life of batteries, finding ways to repair, finding ways to reuse, remanufacture, and that is changing completely the way we manufacture things. It's inventing new manufacturing methods. If you think about it today, the manufacturing methods we have, they never consider the end of life. So we don't manufacture for recycling. That's a big problem. But we don't necessarily manufacture for repairing either. So we need to, the manufacturing methods and the material we use, the welding, the adhesives, it's all about linear. We have the technology for a linear supply chain, which is you make, you take, you make, you use, and you throw away. And that's why our landfills are being, are piling up. And so we need to think of recycling as a process of last resort. We do need recycling, but that's not the only one. So we at ARPAI are looking at these other directions, and that's what this program is about. I think on the regulation side, you can look around the world. There is extended producer responsibility that is taking place in China, in Europe, where the manufacturer of the battery is responsible for the end of life. And maybe you do not want to pay for it, but I'm sorry to say you will pay for it. They will charge you up front because they're going to have to take care of your battery at the end of life, okay? So, and then another thing from the consumer point of view that's interesting, and we are monitoring, is the right to repair. There's a whole movement from consumers like, I own this car, I own this cell phone, and I cannot just change the battery. There are some cell phone, for example, if it breaks, the only thing you can do is throw it away. You cannot even, if you try to open it, you're going to break it. It's designed like that. So I think it goes both ways. I think we can't expect too much from the government, but we are certainly on this topic.
Thank you. Before we go into other topics, I just want to go back to something you talked about. So the aim of the circular project is prolonging the life of batteries. Presumably, prolonging the life of batteries would impact the feedstock that is available to somebody who's recycling these batteries. So how do you see a private company reconciling itself with, the right to repair and prolonging the life of batteries?
This is an enormous challenge. So my point in investing a lot in recycling facilities today is that my concern is we're building overcapacity. We don't have enough battery to feed them. Also, it will depend on the consumer behavior. You're going to have a car and the manufacturer tells you you should replace your battery in 10 years. So in 10 years, you can plan in 10 years we're going to have so much volume because you know what the sales 10 years earlier were. So you can, but this is counting on people to replace their battery as scheduled. And maybe we could have another poll. Who would change their battery, of their EV battery, after 10 years as required by the OEM, the seller, okay? While maybe it's working, you have 80% of the original charge. Maybe you say, hey, I'm going to get 10 more years of this car. I'm just going to drive around. I'm not going to go long distance. So that means that would delay by 20 years, by 10 years. And so the recyclers will be waiting for that battery to come in. So there's still a lot of things in flux.
Yeah, I'll respond to that. You are absolutely correct. I would say right now, I think I would agree that we are building potentially an overcapacity specifically of shredding capacity, so the upfront shredding, we actually are at a lack, I would say, of the end refining piece, which is once we've shredded the batteries, actually turning that shredded material back into metals. That piece, I would say, in North America, we're struggling, but I would agree that at the moment, I would say we have a bit of an overcapacity for shredding. Most of the shredders of battery materials in the United States are actually shredding production scrap because we actually don't have end-of-life batteries to feed at a significant scale to feed these facilities. That being said, if you look at sort of the predictions for numbers, at a certain point, it has been getting pushed back, to your point, actually. Batteries are lasting longer than initially anticipated. Instead of 10 years, we could last 15, 20 years. Obviously, your charge will degrade a bit, but it's kind of then up to the consumer to decide what they want to do with those batteries. There's the potential for second life applications, for reuse, and other applications, if not, say, in your actual vehicle. And so it's a complicated decision to make for the private sector, I would say, right now, is kind of deciding exactly where to invest. So I would say from our side, Glencore's perspective at this stage, we would agree there's maybe too much shredding capacity, but we still need the end refining. But we do believe that at a certain point, probably now, maybe 20 years or so, there will still be a critical mass of batteries available to recycle. And even if it's a smaller feedstock than anticipated, we still will need to recycle them. Once they've reached sort of that actual full end of life, if they've had their second life applications, if they've been able to be attached to a solar farm for additional power or something like that, once it's really reached its end of life, that still has very valuable material that we'll need to recycle. So there is going to be a need for that capacity, and there is still a need for it now, but it might be a little preemptive, I would say, how much development there is at this current stage, given the lack of actual feedstock in terms of end-of-life batteries.
Thank you. In fact, before I ask my follow-up question, actually, I'm very genuinely interested to see who would actually recycle their batteries. So could you ask the question again to get people to raise their hand?
Yeah, what is...
The question about who would actually recycle their batteries.
Yeah, so if you have 80% of your the original capacity on your battery, on your electric vehicle, would you do as you're recommended by the manufacturer and take your car for a battery change for about $10,000 to $15,000 on your Tesla Model Y? Put $100,000 on. Who would do that?
If it was a government car.
If I had a stake in those materials and wherever they ended up.
You will never know that. But there is value, so it will be taken care of. The manufacturer, Tesla, does get their battery back. Not all of them. It's also a business model. Where I talk to some manufacturers, and their model is like, when the car leaves the lot, we're done. This is not our car. And also we recoup the money of the manufacturing. We don't want to wait, right? So it leaves by, we cash the check, and we're done. And this is your car, your battery. At the end of life, it's your problem, not mine. So some maybe have a different perspective. They will try to facilitate the recycling and even take care of it. So this is also business choices, business models that are still in flux. And regulation, government regulation will impact how companies do that. But again, that's not my business.
I will say, just to your point, I think in a perfect world, the end goal, I would say, of trying to achieve real circularity in the EV supply chain is to have the material from your Tesla battery put back in, even if it takes 30 years, back into a new Tesla battery, and actually be able to increase the recycled content versus primary content in those batteries. That is the goal in a perfect world. So that's what we are trying to work towards. Yeah.
Thank you. I wanted to talk about overcapacity for a second. It seems to me that the only kind of company that can contend with this overcapacity is a company of a scale like Glencore's, because it enjoys these economies of scale. It can survive when times are hard, but I don't think the same thing can be said for the startups, for example, that Dr. Pilon is concerned with. So I just want to understand, in the current battery mineral recycling paradigm, is it only companies with Glencore's scale that can succeed? And what needs to happen so that startups also stand a chance? Is it that they identify their niche, or do you see some kind of evolution where startups can play a space as well with the big fish in the sea like Glencore?
I would say, yeah, I think the government stepping in this case, sort of with the IRA and others, and sort of injecting funds into these companies is necessary for the startups to reach the scale to actually be achieving the recycling goals that they're talking about. Shredding is a little bit easier, which is why I think there's sort of an overcapacity there. But the refining capacity, the refineries are huge projects. You need to be processing 20,000 metric tons a year of material at a minimum, sort of, to actually be reaching sort of a profitable scale on these refineries. Those are massive undertakings. I mean, a mine takes 10 to 15 years to develop. From what we've seen, a refinery to get from point A, from start to producing battery-grade material, so material that can actually be put back into a battery, could also take 10 years. It takes a long time to build the facilities, perfect the chemistry, and then perfect the actual end product so that it's something that a battery manufacturer will purchase and put into their product. So I would say what we're seeing now is a lot of partnerships. Glencore invested in Lifecycle, which is a battery recycler, but they're every day they're announcing new partnerships between the major automotive companies and smaller recyclers, just because they kind of will need the assistance to develop that scale. So yeah, I would say we're going to need partnerships, but the benefit of the startups is they're the ones coming with the new technology. Glencore is a massive company. It's like a cruise ship. It's very hard to turn. It's not always going to be the first actually to move in the most technologically progressive direction. So that's why it's really necessary for, I would say, the private sector and then also the government to help support these startups, because we're going to need their technology and their development to actually move us forward.
Yeah, I mean, I think maybe I can give you an example of a startup. I'm supporting a startup right now out of MIT. It's called Lithios, and they have a process to recover lithium from brine and from hydrometallurgical process, and they have a very unique way to concentrate the lithium and capture and achieve the purity you need to put this back into the battery supply chain. So they are sources of innovation. They struggle with scaling, and we accompany them to a scale that is kind of Glencore would be impressed with, right? And so then you could have partnership, you can have investment in the company at different stages, early or later, complete purchase of the company also. So there is still a need for innovation, and we cannot rely only on the big companies. They have a bottom line, they have assets to operate and pay, right? And people to pay. Startups can take more risk on the technology, and this is where RPI kind of steps in.
And for the entrepreneurs in our audience, I just want to understand, what does assessing a startup in this space and their ability to scale look like?
Well, I think for us, we're going to look at the technology. We're going to see, is there any chance that this technology can work? And again, answer the question, if it works, will it matter? And if we see like, yes, it will matter, let's try to help them make it work. And we have different mechanisms, from $500,000 small grants from a program that we call Sparks. 2, we have a program that's called Scale Up or Scale Up Ready. It's out, the announcement is out, it's a rolling application, and we can give up to $20 million. So now you're started talking about having a pilot plant to demonstrate your process at, maybe not at the volume that Mary was talking about, but at a significantly large, it's not a lab anymore, it's a factory. Okay. So we try to accompany them. After that, we only have $500 million per year. Then there are other offices at the Department of Energy, the Loan Program Office, the demonstration of, there's a lot of different mechanisms through which a startup can really take from the lab to the market. And then, but eventually they will have to interact with the big corporation, either as a supplier, as investors, or as customers.
Just hypothetically, let's say I was an entrepreneur, I had a battery mineral recycling startup, and I was lucky enough to go through your program, and I managed to get to a viable scale. I think even if I got to that scale, I'd still have to contend with the fraught geopolitical forces that surround this issue that we all read about every day. And I think scientific advancement and profitability, both of them need to contend with these overarching geopolitical forces. So I want to understand, first of all, how does a private operator navigate this? And how do these geopolitical forces impact the startup space?
So I can go first. I would say, Glencore is a global company, so and a lot of for the scale of these are global supply chains. So while it's very important to develop domestic capacity, it's kind of a inevitability that things are going to be moving across the globe. We just are hoping to limit sort of how far it's moving. It's not amazing for things obviously to be moving from China to Australia all the way back over to the United States and then back again. Obviously that's not perfect for the environment, but it is a complicated issue. For example, most of the vast majority, 90% of the refining capacity that exists for lithium exists in China. So for companies outside of China to compete, it's sort of where we sort of need that combination, I would say, of the private sector's willingness to maybe develop in an area where it's less profitable, essentially, in the sense that China obviously will always sort of be cheaper. So if we're trying to develop outside of China, then you have to take on that understanding. And then that the government needs to then sort of help support it if their goal is, say, to develop capacity outside of China and other countries and develop it in the United States. So yeah, I would say the geopolitical issues are difficult to navigate, but that's why it's helpful when the government does step in and shows sort of their support for building up domestic capacity and domestic production, because it gives both the producers and then also sort of the consumers the surety that there will be support. It hopefully won't be a very expensive product compared to what else is out there on the global market. But it is a complicated issue that we have to navigate often. And I would say it's helpful when the government shows support. And other times, you just have to kind of deal with developing the capacity where it will work the best.
So I think, for us, well, first of all, I want to, China is, all roads leads to China when it comes to battery and battery supply chain. And I think we need to give them credit because they've been working at this for decades. And so we need to think about our way of thinking also needs to be that way. We need to be in this for the long term. And with the change in administration in a democratic society, sometimes the focus keeps on swinging. So the problems remain, regardless of whether the administration changes. So they don't have this problem, and they do invest. So now we have to play catch up. We are behind. definitely, and we are aware of it, and we are investing. But we have to do also, we need to do things differently, because otherwise we're never gonna, if we catch up by doing the same thing, we're never gonna catch up. So that's where innovation comes into play, and I think I have a lot of hope for that, because we are a very innovative country.
And would it be fair to say that instead of the issue of recycling getting lost within geopolitical competition, it actually amplifies it?
I'm not a political scientist, so it's a little hard to say. I mean, we have tariffs, that's like the immediate thing you can do, and that Europe has done, and we are doing is we put tariff on a lot of these things so that slow things down, but we still have to do the hard work. It's just, I think, buying us time.
We have a lot of material here. Our landfills are full of material that can be collected and recycled right here on US soil. So I think, yeah, it's also...
That's an interesting problem.
So,
no, we talk about this. So I have a colleague very interested in that. I'm very also interested. I encourage everybody here to visit a landfill. It's quite impressive. I visited one in LA, the main landfill for Los Angeles, and it's a canyon. It's a canyon that they are filling up, and they already filled up a canyon in Brentwood. And now you have multi-million-dollar houses on top of that landfill. Okay, so we can do amazing things with landfill. It turns out, you just put a little bit of turf at the top, and people will come and buy it. It's possible, but go see. You'll have the procession of trucks dumping things. It's amazing. It's scary. I don't know. So we were like, okay, let's try to mine them. There's a lot of stuff in there. Let's try to mine landfills. Urban mining, right? And we talked to landfills, how would they feel about this? The owner of the landfill, the operators of the landfill. And basically it's like, if you touch the landfill, if you want to extract something, you own everything. So please be my guest, but you want gold, you want copper, cobalt, please go, but we are not taking it back. You take everything and you own it, because there is so much more stuff. There is also danger associated, there's methane produced. So it is challenging, I would say, to do this urban mining. It's something we're very interested just from the technology point of view. How do you go get what you want in this mountain of trash?
One man's trash is another man's treasure come to life. Always nice to see. I think another force that companies and big and small companies like both need to reconcile themselves with is this rapid evolution of battery chemistries as well. You know, we've gone from lead acid to lithium ion, and very soon, hopefully, to sodium ion in solid state. So I also want to understand, before we pass it over to the audience, how do you see startups contending with this evolution, and how does a company with a massive physical footprint like Glencore, because these would affect recycling dynamics as well, I presume.
Yeah, so I would say that's maybe to the point about how difficult it is actually to deal with the various chemistries. Is why we're seeing an overcapacity for just, say, the shredding side. It's pretty easy to just throw a battery of any chemistry or any sort of scrap into a shredder and shred it. Batteries, obviously, it's a little bit more complicated because there's the potential that it'll light on fire. So it's more dangerous, I would say, than, say, a traditional scrap material. But in general, it's a pretty standardized process. The next stage is where it gets much more difficult, and I would say is where the smaller companies are sort of having their issue. You need to be chemistry agnostic. You need to be battery type agnostic, size agnostic, really, to have a company that's going to be sustainable in this ever-changing environment. Right now, for example, we're seeing a big increase in LFP batteries, so that's lithium iron phosphate batteries, but lithium is actually really difficult to recycle. Most of the processes we have for battery material processing globally is a pyrometallurgical process, which is essentially you just kind of burn off all of the extra material, but unfortunately you also will burn off the lithium. So what's being developed right now is hydrometallurgical technology, among other technologies, that will be able to recover that lithium so it actually can be recycled. But it's important to have, which is difficult, but it's important to have a technology that can very quickly, I would say, adapt to the different varying chemistries and the changes that we'll see, just because they're going to change very rapidly. Right now, we're in a phase of serious innovation. We've gone from lithium-ion batteries to sodium-ion batteries very quickly, I would say, relative to the development of other technologies. So it's essential sort of for the survival of the startup companies to be able to adapt quickly to those changes.
I would start by answering your question by saying that first, there is no battery chemistry that has disappeared. So lead acid batteries were discovered 150 years ago. We still have them, and the projection, the demand is growing. Okay, it's growing of 3% per year. It's still growing. So there is no battery chemistry that has disappeared, that has been replaced by something else. So that's the first thing. Even though LFP is starting dominating now, I mean, right now the prices are amazing. $50 per kilowatt hour for LFP. This is not even in the 2030 projection of price. It has come down by 40% since last year. Okay, so now this is taking over the market. But NMC, nickel, manganese, cobalt oxide chemistry is still growing. The volume of production is still growing also. We're going to need a lot of batteries in the next 40 years. So even though the fraction may vary, all chemistries are still going to grow. So having said that, I mean, the point is, how do you deal with so many different chemistries? So what we hear from manufacturers is we're going to have a need for standardization. It's for a recycling process, if you only have one chemistry, you can really optimize your process for that chemistry, and you can really reduce costs, increase the efficiency of your recovery rate. But obviously, we're not there yet. The recyclers, that's the challenge. They get all kinds of chemistries, all kinds of shapes. It makes everything very difficult for them. And again, I think this is the manufacturers don't think about who make this thing, do not think about the recycler. Really, this is like, I joke with the recycler. I say, you're in an abusive relationship here because they need you and you need them, but they never do anything for you. They'll dump it on you and say, oh yeah, somebody's going to recycle. Well, what happens if you only have LFP? Then that's what I created this program, Circular, because we could see LFP taking over. Cobalt and nickel recovery pays for the entire recycling process. So if there's no cobalt and nickel in the battery, how are we going to make money? And so we need to think about other ways to do it. But if you have just lithium-ion batteries, you're going to have a lot of recyclers going under. Unless they try to, like Glencore, they'll get different chemistries and they're going to make it work. But we have to worry about that. So the idea that somebody's going to recycle in the future and they'll figure it out, maybe we have a process, but will they make money? And if they don't make money, why should they recycle? And then we're going to have an enormous amount of waste. Right now, do you guys know how much the fraction of fire in landfills? What is, landfills catch on fire, sometimes there's methane. What fraction of this fire are due to battery catching on fire? 70% of the fire in landfill are because of battery catching on fire. Do you know how many fires are occurring in a material recovering facility every day? 10 in the country. 10 fire every day. Once a month, there's a MRF, a material recovery facility that shuts down. So it's the entire recycling facility, because there was a fire and a big one. So the conveyor belts, everything caught fire, and it's just, you have to rebuild it. So fires and batteries cause all kind of problems. They are energy dense. They have a lot of energy in there, and if you puncture them, they'll catch on fire.
Thank you both very much. It's time now to turn to the audience. I think it's small enough that we can do an open outcry. So if anybody has questions, just stand up and go ahead.
Dr. Pilon?
Sorry.
I'm sorry. Thank you. This was terrific. I wonder if you could speak to the most challenging bottlenecks in the circular economy right now. You both mentioned feedstock, and I think refining capacity, but just curious what the most challenging areas are to the fully functioning, efficient.
Yeah, so from our side, yeah, I would say feedstock, but because of that collection, right now it's there is extended producer responsibility in places like Europe, but that doesn't exist as much here in the United States. So specifically for end-of-life batteries, they at the moment could end up all over the world. So it's difficult. The first stage is actual collection of the end-of-life material. And then another big piece I would say is, just on that note, is we need a little bit more, I would say, buy-in from the producers, the OEMs, the automakers. At the moment, they verbally are saying that they are very into a circular economy, into recycling, into those sort of things, but we need them to actually provide the recyclers with the material. So if they, whether that be their production scrap currently or having some sort of system to actually gather the end-of-life batteries at the end to make the feedstock work. And then another big piece is, as you just were mentioning, is the batteries are really dangerous, so to move. So a big piece is transportation. It's actually very difficult to find certified carriers who can transport whole batteries. That's why it's really one of the pieces that we're seeing recently that will be very helpful is co-locating shredders with collection networks or even dealerships or something like that, so that the batteries can be, once they're done, once they've reached really their full end of life, or they're going to be moved to that, or it's decided that they're going to be moved to recycling, shredding them as soon as possible, because once the battery is shredded, the hazard is gone. They're not going to light on fire anymore. Of course, the materials themselves, cobalt, lithium, are hazardous, sticky metallic, and all of that, so you need proper PPE. But a big piece right now is transportation. It's really difficult to move batteries globally. Yeah, that, and then along with the capacity. Right now, we don't have a good domestic builds up of processing of that end refining capacity that will actually be within North America producing those end metals.
To me, one of the main challenges, one is the supply chain and how you distribute the value across the supply chain so that you don't have one of the elements breaking down. For example, recyclers, if you only feed them lithium iron phosphate, LFP batteries, they can't make money right now. So then that drops, and then what do we do with the waste? Another one are the dealerships. The dealerships, they don't like to sell electric cars because they make money from the loan, from you may buy your car with the car loan, and they'll make a cut on that loan, but they'll make money on you coming back regularly. But you can't do that with an electric vehicle. You do not need to do that. You just change the tires. The tires on the electric vehicles wear out faster than So what's the deal for the dealership? And in most states in California, in the US, most states, the cars must be sold through a dealership. And so you may have actually some OEMs are worried about that, their network of dealership, because they need to survive. So I think the supply chain and the value, or spreading the value around is how you make it sustainable. And I mean, okay, that's my analysis, okay? On the technology side, it's just the manufacturing and the material we use to make these batteries. We need to reinvent the technology to achieve a circular economy, while all the technology we have today are for the linear economy. So linear supply chain.
So,
Dr. Van, thank you very much for a great panel. I just pinged the CEO of our battery startup setting up their pilot facilities in Miami, and he goes, "Oh, ARPA. Like, I'm going to go in and talk to ARPA." What is it like practically for a technical founder who's starting a business for the first time to engage with ARPA? Do you have any guidance on how to do that tactfully or patiently or
I'm not
easily?
understanding what is we are very plugged in. We see a lot of things, so obviously we are skeptical of everything, and but we hope that if we see something good, we will not pass it. So convince us that it's good, but we will listen for sure. Whatever you have, we listen. Send us an email. We have calls. I have countless calls, or we can talk after this conversation. You just need to make your case. And again, the question is, if it works, will it matter? Sometimes we get people who are enamored by their technology, and it's amazing. It works. Great. But that's not enough. It needs to matter. And that's often that's what's the piece that's missing. So, yeah.
Yes, Hunter Dare from Columbia's Sustainable Finance Program. As you look toward utility scale storage, 100-hour storage, and seasonal storage, what materials do you see being successful when we get those things developed? And are those things being developed with kind of the circular economy in mind, or are we going to have a lot of waste out of those processes?
So, can I answer this? We think a lot about energy storage with my colleague Hallie Cheeseman. The question I would have for you is, do you think we're going to use battery for long-term storage? Maybe not. Probably not, particularly 100 hours. 8 hours, great. Less, more than that, maybe we need another technology. So we have in our portfolio other technologies, maybe more thermal, maybe more. We have a portfolio of technology for longer term. We have a program called DAYS that looks at between 10 and 100 hours energy storage. And it's not just battery, it's a lot of other things. And incorporating these long-term storage or grid storage or large-scale storage in a circularity mode is, so there's a lot of talk about using spent battery from EV for the grid as a second use. I was just in a meeting with some of these companies that design battery system for the grid, okay? And they are designing it to last 20 years. Their customers want reliability, resiliency, etc. They are not going to use used batteries, and they can buy LFP for $50 per kilowatt hour. They buy brand new cells. So the second use market is questionable at best, and then it's still a linear process. It's still, you just add one more step. You take, you make, you use, you reuse, and then you throw away. So it's not closing the loop. It's just prolonging the life by another application. But again, even that is not clear whether there's a market for that or not. Maybe to go from EV to scooters, that's doable, and that's being done. I talked to startups in the Bay Area, that's what they do. But this is something that OEMs don't really want to, right? A great battery is Nissan. Nissan Leaf has some pouch cells that are very easy to disassemble and very easy to repackage into a scooter. But does Nissan want that with their cell? Who is liable for that second use? Is it Nissan, the original manufacturer, or the? It gets complicated very quickly. So.
Yeah, I would just add to that, it is very difficult. So, like, we've spoken to a number of Second Life players who are attempting to use specifically old EV batteries and put them into Second Life applications. You need a very consistent feedstock to make those sort of products. The battery management systems of each of the different each type of battery, each automotive company, they're very different. And so you need to really sort of jailbreak, for lack of a better word, the batteries to sort of be able to make different batteries work together into one Second Life product, and that could lead to a lot of danger, potential for fires and things of that nature.
Thank you for the presentation. Are there any real-world successful urban mining operations, or is it still totally conceptual at this point? The landfills that you referenced.
I do not know any. People are looking into it. We are talking to some of them to try to see how we can help them. But again, who owns the waste after, and this is the biggest challenge, I think. And the technology-wise, it's not easy either, obviously, because this is enormous volume, and you're looking at, it's a large volume and very small amount of variable material, so you have to, it's better than mining, okay? If you go mine cobalt, you may have more cobalt, concentration of cobalt in the landfill than in earth. So there is value there. There is stuff that we know there are critical minerals in the landfill more than in the regular mine, but it has some challenge.
Hi, what are your views on technologies like phytomining and bioleaching? Are they commercially viable and scalable in the long run?
So we have a program on phytomining by my colleague Phil Kim. Again, we have a portfolio. We take high risk, we look at for high risk, high reward projects, and we have a portfolio. We take multiple shots on goals. This is much further. It's not as developed as a lot of other things. So yeah, phytomining is you grow plants, and for those of you who do not know that you grow plants and they concentrate some of these metals. So there are plants that concentrate nickel. So you grow them in the ground rich of nickel, and then you harvest the plant. Obviously, that sounds crazy, and but crazy is a compliment for us. So it's doable, so that's good. It's crazy and doable. That's the kind of thing we like. Can you make it work? It's a challenge, but we're on it. We just put, I forgot, maybe $15 million on this.
Hi, my name's Rose. I'm a senior at Yale College. This has been a really interesting talk. I wanted to ask about different kind of success rates with battery recycling and kind of what that looks like across different battery recyclers and what it looks like between different types of batteries. And to a certain extent, at a certain point, if we can't recycle enough of the batteries, it makes more sense to focus on energy efficiency instead. And then what kind of enables successful battery recycling?
So it varies a lot across the different types of batteries. Like Dr. Pilon mentioned, lead acid batteries. We at this point the process of recycling lead acid batteries is like 99% efficiency. You can get almost all of the material back out. I would say right now the startups, they're sort of competing with each other in terms of like the lithium-ion batteries on the technologies to improve that efficiency. Once it's actually through the system, I would say for the chemistries like a nickel cobalt chemistry, you can recover 95% of those materials. Lithium, which is kind of the piece that we've been discussing that's a little bit harder to work on, you probably can recover maybe about 60% if it's incredibly efficient at the current technologies we have, at least in the United States. I know in China, for example, I think that's close to 95% there. So you can get the materials back out quite efficiently. It's just a matter of, I think developing the scale to do so. And then in terms of your last question about energy efficiency, I think we will still have the feedstock to recycle the batteries, but I think we're already seeing that they're lasting longer. The lifetime of the battery is longer than we anticipated. So I think improving the energy efficiency is going to be important just for the longevity of the battery, because we want to keep it alive for as long as possible and avoid putting it back into the recycling until it's absolutely necessary.
I think last question.
Thank you. Thinking more about utility scale storage and making this circle smaller by having dual use of batteries already made. So to what extent could a fully electrified transportation fleet, be made to a distributed storage system in the grid?
Yeah, so we have projects on that where you can, a car is at rest 95% of its lifetime. Okay, the car we own, we're here, right? Where is our car? So you could, if you plug it to charge, then you could use it as a storage for the grid. So now you need bidirectional power electronics to enable the charge and discharge at will. There's also a relationship with the utilities. How much do they charge? Do they pay you to use your own battery because that's yours? What if they own it? Then maybe you just own the car but not the battery. Maybe that would make the car cheaper. So there are technology and business and what if they fry your battery? What if they charge it too fast and it's a cold winter day, they charge it too fast and your battery gets damaged and maybe it dies 5 years earlier than you had expected and it's on you to repair it, to replace it. So there are technology needs and also technical challenges and business needs that are not clear, but there are people working on it and some of them are our performers.
I think that's all the time we have for today. I'm very, very grateful to the both of you for coming. Thank you to the audience for your insightful questions, and I hope the next time you're in a Tesla or the next time you grab a TV remote or your phone, you're filled with some extent of optimism and an extent of responsibility. Thank you very much for being fantastic.